Okay, so we just finished talking about what happens when two functions are adding or subtracting. And when we take the derivative of two functions adding or subtracting, it worked out really nicely because we can just do the derivative of one plus the derivative of the other. Now, when we have two functions multiplying, one might guess, right, that we might just be able to do the derivative of the first times the derivative of the second. But unfortunately, that is not how derivatives work. If you were to go through and try to derive the derivative of two functions multiplying using that limit definition, that is not what the derivative will give you. Instead, we have to get ourselves a new rule. So this is what they call the product rule. It's going to become really important. It's something that it's really important that you sort of get down, this product rule, and it looks like this. So the way I would write it is I would do f prime of x times g of x plus g prime of x times f of x. Although I will say that sometimes I've seen students have this memorized from other classes, and sometimes they might have the order of those two terms the other way around, right? And that's okay. So if you have a way to memorize it and you want to check and see if it's the same as what I'm doing, come and talk to me in the office hours or talk to me before or after class. But, you know, something that looks sort of like this will give me the derivative. Okay, so for something like this one, I've got the f of x is equal to x squared times x cubed plus 2. So you can kind of see that there's this first function and then it's times the second function. So I always like to kind of do like a fill in the blanks thing. So we'll call that thing f, we'll call that thing g. And then from here, oh, I guess it's kind of weird because I did call this function f of x here. Let's change it. Let's call this h of x. Haha, there we go. Then I can keep using f and g. So if I want the derivative of h of x, so that would be h prime of x, I'm just going to write out my fill in the blank here. So according to the rule, it's supposed to be f prime times g plus g prime times f. So it's just fill in the blanks here. So let's fill in the ones that we know because we already have f, it's given. So f was the 3x squared. So I'm just gonna, oops, let's do it in black. Here we go. 3x squared, so we're just gonna fill that in. And then the g was already given, so we'll fill that in. That was the x cubed plus 2. Now f prime, that's the derivative of the 3x squared. Now to get the derivative of that thing, we've got a constant in the front. So we've got 3 times, and then the derivative of x squared, which is 2x. And then from there, we also need to work out the derivative of g. So g was the x cubed plus 2. The derivative of the x cubed part is 3x squared. That's our power rule. And then the derivative of 2 is 0. So it sort of seems silly that I stuck it there. Let's stick it in the middle. 3x squared. That's the derivative of x cubed plus 2. Then from there, it's really just sort of simplifying. So in this case, let's see, so we'd have 6x times x cubed plus 2 plus, and then we'd have 9x to the 4. And then we might even go a step farther and actually multiply this through to be able to get an answer. So let's see, we'd have 6x to the 4 plus 12x's plus 9x to the 4. So that is certainly one way to take the derivative here. We have two functions multiplying each other, and so we could definitely use the product rule. Now, depending on the original function, I do want to point out that we always, always, always can do algebra first before we go through and take the derivative. So another option here, maybe I'll write this out as like option 2, do some algebra first. Okay. So in this case, this h of x, I could go through and actually multiply that 3x squared through. Okay. So I would, if I did that, I'd have 3x to the 5 plus 6x squared. So I've done my algebra first. And then from there, then I can go through and take the derivative. And I don't have to use a product rule because I don't have two functions multiplying, they're adding now. So I'd end up with 15x to the 4, that would be my power rule with the constant multiple in front, plus 6 times 2 gives me 12x to the 1. And that should match up with what we did before. Aha, look at that, I didn't fully simplify. This term here had some, this term here had some x to the 4s, and this one has that. So if I've got 6x to the 4s plus 9 of them, I've got 15 of them. So I should have just gone one step farther. 15x to the 4 plus 12x. And look at that, we're getting the same answer either way. So that's perfect. So I always encourage students to, be checking your rules multiple different ways, just to make sure that you're getting the right answer. And that way when you walk away from your test or your quiz, you can go, yes, I got it the same way, both ways. And that can feel kind of good. So don't forget, you can do a little bit of algebra first. And in this case, it sort of allowed us to avoid the product rule. That won't always be the case depending on, the functions f and g that they give you. But in this case, we could. So lots of different ways to take the derivative of this one.